Okay, so for our first lesson in week 26, we're going to have a look at the chain rule for differentiation. The chain rule for differentiation is something that you have used already without giving it a name or actually writing down what the rule is, which is actually a very good place to be, as we'll see in a minute. So the chain rule for differentiation helps us to differentiate functions which are composite functions, i.e. they are functions of functions. Now you can see from this example here, y equals 3x to the 4 plus x, all raised to the power of 5. So we can say that's a function of a function because it's this function of x in the brackets that you would work out first, and then you take that function and you raise it to the power of 5, which is in fact invoking another function afterwards. So there is a rule that helps us with this, and it is the chain rule, as I just said. Now the chain rule for differentiation is as follows. We use properties of fractions. So if we were trying to find dy by dx, we're going to write dy by dx as the product of two fractions. Now dy by dx, this is very important, dy by dx is not a fraction as we know it, but it behaves like a fraction. So all rules of fractions can apply. So we're going to write dy by dx as the product of two fractions. Now I've split it up, dy on the top left here, dx on the bottom right. These are my two fractions. Now what I need is something on the denominator of this fraction, which is the same as the numerator of this fraction, so that when I multiply these two fractions together, these two things cancel. And I'm going to use du. Now, just following the rules of fractions, if you multiply dy by du, multiply it by du by dx, the du's cancel and you end up with dy by dx. So we haven't broken maths here. All right. Now, how is this useful? Well, let's have a look back at our function of y. I'm going to say, let's let u equal 3x to the 4 plus x, i.e. the part that's in brackets. Okay. So this means that y is going to be u to the power of 5. Okay, the bracket to the power of 5. And we've got our u equals 3x to the 4 plus x. Now for this chain rule to work, we need dy by du, which we can get from here. We differentiate y with respect to u. So dy by du is 5u to the 4. Du by dx, which is this part here, is given when we differentiate this part. So we've got du by dx, which is going to be 12x cubed plus 1. Okay, so we've just differentiated u to the 5, we've differentiated 3x to the 4 plus x, and we've got these two things. So this means then that our dy by dx is dy by du first, 5u to the 4, multiplied by du by dx, which is 12x cubed plus 1, which I've put in brackets because we're multiplying the whole thing. And all that remains is to write down what u was in the first place. So u was 3x to the 4 plus x. Not 3x plus 4, 3x to the power of 4. And that's our derivative. Now the way that we'd commonly write that, I suppose, would just be to say 12x cubed plus 1 multiplied by 3x to the 4 plus x to the power of 4, just to make it very clear that this bracket has a power, because sometimes it can get a bit muddled in the middle, but it's the same expression. So we're now entering into a world, and for the rest of this week and for the rest of the course really, where when we differentiate a function, the answer ends up looking a lot more complicated than the question. And that goes against everything we've looked at in differentiation so far. Whenever we've differentiated, our functions tend to get smaller, but now they're getting bigger because we're going to be applying some rules here. Now, where we want to get to with this is where you're doing the chain rule just by looking at the function. So if I was to look at this y equals 3x to the 4 plus x all to the power of 5, if I was to differentiate in my head, I'd be bringing this 5 down to the front and reducing it to 4, which is what we do when we differentiate. Then I'm going to be differentiating the bracket and multiplying the two things together. And that's where we want to get to. And the reason for that is because we're going to learn a few rules this week. And this one is part of the other rules. And by that, I mean that you will have to use the chain rule as part of the questions that we're going to do later in the week with the product rule and the quotient rule. So the quicker you can get to the point where you can do this without doing all of this working, the better. And it's not often that I say that. So let's have a look at another example. Given that y equals the square root of 5x squared plus 1, find dy by dx at this point 4, 9, which is what we would do if we were asked to find the equation of a tangent, for example. We'd be actually finding a gradient at a point and using that gradient and that point to find the equation. So let's remind ourselves, the chain rule is where we take our dy by dx and we split it into the product of two fractions, where we introduce a third letter, which we're going to use u. So let's then go back to our function. We've got y equals that square root of 5x squared plus 1. That's the same as 5x squared plus 1 raised to the power of r. Now we're going to let u equal this 5x squared plus 1, okay, the thing that's in the bracket, which means that y now becomes u to the power of a half, and we're going to find dy by du and du by dx. So dy by du here is going to be 1/2 of u to the power of minus a half, just differentiation, okay? Multiply by the power, drop the power by 1. Du by dx is going to be 10x. Differentiate that. And then we combine the two things together so that dy by dx is our dy by du, 1/2 u to the minus 1/2, multiplied by 10x. And then the final stage is to actually put back in what u was, which was 5x squared plus 1, multiplied by 10x, and then write the answer as simply as we possibly can. So 10x multiplied by 1/2, we've got 5x multiplied by 5x squared plus 1 to the minus 1/2. And we can stop there. It's absolutely fine to leave your answers with a negative power, but if we wanted to simplify it a bit further, we could say that that's 5x over square root of 5x squared plus 1. Okay, but just to repeat, this is fine. So again, that's our chain rule. Now, if I was to do that without using an explicit rule for this, which again, remember, is where we want to get to, writing the question with the power of a half is really important, all right? So we're going to bring the half down in front of the bracket, reduce the half by 1 to minus a half. Then we differentiate what's in the bracket and we multiply everything together, all right? That's what this chain rule is doing. And yeah, the sooner we get to doing it by sight, the better. So now we have one final example that kind of falls under the chain rule topic, but this is just where we're finding dy by dx at a point where the equation looks slightly different. This equation isn't y in terms of x, it's x in terms of y. And to do this one, all we're basically saying is that dy by dx is just 1 over dx by dy. So don't be thrown if you're given x equals something in terms of y. Differentiate as normal and then use the reciprocal of your answer. So if we had a look at this, x equals y cubed plus y, we can find dx by dy. Differentiate x with respect to y, which is 3y squared plus 1. And then using this little idea here, then dy by dx is just 1 over this 3y squared plus 1. Now that, don't worry about this, okay? Just because your dy by dx has a y in it instead of an x doesn't actually matter. We can still evaluate the gradient. So at the point 2, 1, y is 1, isn't it? That's the y coordinate. So we can say dy by dx is 1 over 3 times 1 squared plus 1, which is 1 over 4. So we still have the gradient of the tangent at that point. We just use y instead of x. So now it's about practicing this chain rule. And we're going to look at it with regard to our exponentials and logs that we've already been working on. So this is where I said you've already been working with the chain rule. We just didn't really call it the chain rule. We just said put the k value here. Now let's have a look at this, okay? This function here for question A. Y equals e to the 3x plus 2 to the 3x. I'm gonna treat these separately first, right? So I'm going to separate them, and I'm going to start with y equals e to the 3x. Okay, I'm going to differentiate those separately and then add them together at the end, which is what we do anyway. So we'll say let u equal the 3x. All right, the function of the function, e to the power of the function of x. So that means that y equals e to the power of u. It means that dy by du is also e to the power of u, because when you differentiate e to the power of something, you get e to the power of something. Du by dx, when we differentiate the 3x, we get 3. And remember, the chain rule says that we multiply those two things together. So dy by dx is dy by du, e to the power of u, multiplied by du by dx, so multiplied by 3, which is e to the 3x multiplied by 3, which is 3e to the 3x. Now that's why when we differentiated exponentials and logs last week, that's why the 3 was multiplying the function at the end, because of the chain rule. So that's our e to the 3x. Now let's have a look at 2 to the 3x. And we're going to let u equal the 3x again. And that means that y is 2 to the power of u. Now when we find dy by du this time, we use that standard result that we learned last week, which is going to be 2 to the u multiplied by natural log of 2. And then du by dx, again, it's just 3. When we multiply the 2 together to make dy by dx, we've got 2 to the u log 2 multiplied by 3. We swap in our u, so we've got 2 to the 3x log 2 multiplied by 3, which comes out as 2 to the 3x multiplied by 3 log 2. And that's exactly what we did last week as well, but we just used the fact that k is this and k goes there. So dy by dx then, for the whole function, remember these two were added together, e to the 3x plus 2 to the 3x. We just take our two derivatives and add them together. So 3e to the 3x plus 2 to the 3x multiplied by 3 log 2. Okay. So hopefully there's nothing too complicated there. Again, last week, remember, we learned to differentiate these on site by using k goes here and k goes here. Now we're just looking at the fact that this is actually the chain rule and how does the chain rule work. And again, to repeat, we want to get to the point where you can do these on site rather than writing out this kind of masses of working for each of these questions. We should be able to just say e to the 3x differentiates to give 3e to the 3x, and 2 to the 3x differentiates to give 2 to the 3x log 2 multiplied by 3. So let's have a look at question B. I'll write the function out down here, just because otherwise I'll be screwing up all the time. Log of x cubed plus log of 7x. Now, Using the chain rule for the first part of this actually does waste time, and we're not all about wasting time. So I'll show you that I'll remind you of, I should say, the quick way of doing this at the end. But we're going to have a look at how the chain rule works with this first. So we'll do them separately. And we'll concentrate first on log of x cubed. And we're going to say, let's let u equal the x cubed, because it's the function of the function. Right? So that means that y is just natural log of u, meaning that dy by du is 1 over u. Remember, that's that standard result we learned last week. If you differentiate a natural log, you get 1 over. Du by dx is 3x squared. And then for dy by dx, for this element, we're going to multiply the two together. 1 over u multiplied by 3x squared. Remember that u is x cubed, so we've got 1 over x cubed times 3x squared, which is 3x squared over x cubed, which actually simplifies to 3 over x. I'll come back to the quick way of doing that in just a sec. So that's our first element here. So we're doing these separately. So now we'll do the log of 7x. And we will let u equal the 7x, so that y again becomes natural log of u, meaning dy by du again is 1 over u. Du by dx is just 7 when we differentiate the 7x. Dy by dx, therefore, these two multiplied together, 1 over u multiplied by 7, which is 1 over x. Sorry, 1 over 7x multiplied by 7. Which is 1 over x. So our final answer, dy by dx, these two combined together, we've got 3 over x plus 1 over x, which is just 4 over x. Now, the quick way that I was referring to earlier about this y equals natural log of x cubed, what we can actually do here is just say that's 3 times natural log of x, okay? And then dy by dx is just 3 multiplied by 1 over x, which is our 3 over x. Now that is a far faster way of differentiating that when you remember your laws of logs. But you can do it both ways, okay? The chain rule works, and so does using laws of logs. So that's the chain rule. And the rest of this lesson is going to be about practicing, just practicing, differentiating functions, finding equations of tangents, etc., etc. All right. Thank you very much. Next, we're going to have product and quotient rules.